We have another trigonometric identity question here from paper 2020. Find all solutions of the following equation in this range, 0 to 360 degrees. Okay, so from the equation, we can see it's 4 cos squared theta plus 2 root 3 minus 1 sine theta equals 4 minus root 3. So we want sine theta or cos squared theta. We want it in just one of them. Quickly, we can see that cos squared theta equals to 1 minus sine squared theta. Okay, and that is from an identity you should remember, which is cos squared plus sine squared theta equals to 1. So therefore, cos squared theta, we can write it in terms of sine squared theta. This identity is very useful to change any cos squared theta or sine squared theta into the other opposite. Okay, so this would become 1 minus sine squared theta plus 2 root 3 minus 1 sine theta. And whilst we're here, we might as well move the 4 minus root 3 to this side. Okay, so then that would become minus 4 plus root 3 equals to 0. Okay, then we can expand this out. So we'll get 4 minus 4 sine squared theta. We'll leave this sine theta term with the brackets like this, because we might not have to expand it. Minus 4 plus 4 root 3 equals to 0. Now the 4 and the minus 4 cancel out conveniently. So we might as well times by minus 1 whilst we're here. So we're timesing everything by minus 1. So this would have to become minus 2 root 3 minus 1 and minus root 3. Okay. Now we can do a substitution here, which will be x squared equals to sine squared theta and x equals to the sine theta. It's the same substitution, but I'll write out both of them just to make it a bit easier for you. So the 4 sine squared theta will become 4x squared, and that will be minus 2 root 3 minus 1 x minus root 3 equals 0. Now this is a quadratic. You could solve it using quadratic formula in your calculator, but we'll try to factorize it. So two numbers that times the a and the c to give us minus 4 root 3, and then we want two numbers that times to minus 4 root 3 and add to minus 2 root 3 plus 2. So clearly we want those two numbers, minus 2 root 3 plus 2. Now, if you have any problems here with the factorization, I would say just use a quadratic formula. But here we can see it works out nicely for us, so we'll continue. So it'll be 4x squared minus 2 root 3 x plus 2x minus root 3 was 0. So clearly you can see that will be 2x minus root 3 plus 2x minus root 3 if we factorize the first two. And then that will become 2x plus 1, 2x minus root 3 equals to 0. Okay. Now just create some more space for us here. Then if you set this equaling to 0, you get 2x plus 1 equals to 0, x equals to minus half. So sine theta will equal to that minus half. And over here we'll get 2x minus root 3 equals to 0. So x will equal to root 3 over 2. And then remember x was sine theta. So sine theta will equal to root 3 over 2. Then we can inverse to get two sine values, okay? So I'll just use my calculator to do that. This is the calculator paper now, so it's fine. So that will be 30 degrees. Then remember that sine theta equals to sine 180 minus theta. So we can also get 150 degrees from that. Okay. But actually, take that back. So here, sine minus half, we put in the calculator the inverse, we get minus 30 degrees. And then from this one, we'll get sine minus root 3 divided by 2. Sorry, just root 3 divided by 2, not minus. Will give us 60 degrees, okay? Now we can use CAST, the cast diagram, like that, to give us the values. So we measure clockwise here. So the minus 30 will be anti-clockwise. So that will be minus 30 there. And because this is minus half, we want to go to 1. This is where cosine is positive, all positive, sine positive, tan positive. Now, because cosine is positive here, not sine, we want to go to somewhere where sine is not positive again. So that would be here. So in the T, because sine is positive in sine and we want negative, so we need to reflect it into the region where sine is no longer positive, which would be this region, and that will give us a value of 210 degrees. So if you measure that way, it will be the 180 plus the 30, which is 210. Now the other value is 60 degrees, so that will be here. We'll make that a bit thinner for us. So that will be here, which is 60 degrees. And then we're positive. We're root 3 over 2 is positive. So we want to go into the other region, which is positive, which is here. We've reflected it there. So that will be 60. And then this value here, the positive value here, will be 180 minus that 60, which will be 120 degrees. Okay. So that will be 120 degrees. And those are the 4 values. Okay. Now, actually, they wanted it just between 0 and 360. So the minus 30 is the correct value, but it's not between 0 and 360. But there's another way we can reach there, which is if we go all the way around, and that would be 360 minus the 30 degrees. So that would be equal to 330 degrees. Okay, excellent. Great. Hope that made sense.